I have this force 200 newtons. Nothing from, I mean, the friction force will not show up in the side view, only the tip of the arrow will show up, you know what I mean? So this is the only force from the side view. So the bending moment for that, this distance is 100 mm. And let's make sure we know the axis. So this one is the x-axis, this one is the y-axis. Can you see that? And now this time it's rotating that way. It's going x cross y. This is in the z direction. So as usual, our bending moment, this is mz equals 200 times 100, which is 20,000 Newton millimeters. Okay, so now we are ready to compute m, the total moment. How much is the total moment? This will turn out to be square root of my squared plus mz squared, which turns out to be square root of 6,000 squared plus 20,000 squared, and that turns out to be 20,900. And this is the cyclic torque. This one, the axial force, this comes into mean force. It's steady, you know, it's not changing, it's just pushing steadily. Now we are ready to compute all the other things like what we did. So remember, we have now computed the 3 views, found the moment in each view. The way to do the moments, total moment, is to take square root of a squared plus b squared plus c squared. Okay. In our case, torque we calculated separately, and the 2 bending moments you have to do a squared plus b squared. Got it? So now we are ready. We are going to look at the cross section. So again, I'm going to switch to doing this using Excel, because we can do the calculations. So let us write down here. So this one is alternating loads, and here is the mean loads. So first one is bending, torsion, and axial. Again bending, torsion, axial. So in our case, alternating bending load was 20,900, no alternating torsion, no alternating axial, no mean bending. Mean torsional was how much? Let us see, 12,100. Sorry, 12,000. And then mean axial is how much? 6,000. No, sorry, minus 200 newtons. So by the way, let us make sure, because I never want to write, this is Newton millimeters, this is Newton millimeters, this is newtons, again Newton millimeters, Newton millimeters, Newton. So next we want to find out MC over I is the stress, TR over J is the stress, F over A is the stress, MC over I, TR over J, F over A. That's what you have to do. Okay. So let us compute all of this. So diameter 16 mm. Okay. I'm going to write diameter 16 here. So I don't want to put it up. I'm going to do that on the side here. Okay. So diameter 16 mm. Okay, so C is 8 mm. I don't know whether you remember, it is pi times d fourth over 64. Okay, so I'm going to write this as d over 2. So this is 8. This is pi d fourth over 64, which turns out to be pi times 16 fourth divided by 64, R is d over 2, that's 8, J is equal to pi, so let's write it down here, pi d fourth over 32. So this is this times 2. So let's do this right, equal to that times 2. Okay, so we got everything. So we go back here and we compute, equals this times C divided by I, 52 Newton meters, TR over J. Let us do that. So that is 0, we don't have to worry. That's 0, we don't have to worry. That's 0, we don't have to worry. That one will be equal to that times R there divided by J, 14.9, and then we got to do F over A. That's easy. F divided by, sorry, that's equal to F divided by pi times d fourth, sorry, d squared over 4. So that's very, very low. F over A is only 0.1 MPa. I mean, it's only about 1 MPa. So it's not even, look at that thing, okay. Bending stress is 51 megapascals, torsion is 15 megapascals, that's 1 megapascal. You don't even have to, most of the time you don't even have to worry about axial, but I'm just doing it brutally so that you can see what happens. Okay, now we have to compute the stress concentration factor, KT. You can go look it up, and it turns out to be, let's see, KT for this is 1.27, KT for this is, I don't care about all of this, KT for this is how much, 1.06, and then KT for this, you might get slightly different numbers, but you will be close. Okay, then you have to compute the this one, what is that, the notch sensitivity. Notch sensitivity for this is 0.91, notch sensitivity for this is 0.92, under torsion, axial is the same as bending, 0.91. So that means the fatigue stress concentration factor equals, in fact, equals 1 plus this times that minus 1. 1.25. I'm going to pull it across. I don't really care about all of this. There. So I'm going to round it up to 1.25. There's no point in being cute and saying 1.2457. Okay. All these numbers, don't worry about them too much. This is stress. Okay. Now we can compute corrected stress. Which turns out to be equal to this times that, equal to this times that. equal to this times that. There. So these are the actual stresses. So now we're gonna switch back. And I'm going to go back up here. So now we have our corrected stresses.